Now in this video we will look at lower bound and greatest lower bound. Okay, I have made some changes in the Hasse diagram from the previous video. So what is the lower bound of S1? Lower bound of S1. So what is S1? What are the elements in S1? C and H. C and H. Okay, so what elements will be there in the lower bound of a set? All those elements that is related to every element in the set. So all those elements will come here in this set that is related to C and that is related to H. All those elements that is related to both C and H. Okay, for example, if you look at this B, then B is related to C and B is related to H, so B will be here. Now let's find out all the elements, or let's find out the lower bound of S1. So from C, you go one step in the downward direction. There is A, there is B, and there is J. Out of these A, B, and J, so what I am doing right now, I am trying to get to the point of meet. Okay. So A, B, and J, A is related to C, but A is not related to H because there is no upward path. From A you can go to C, but then from you can go to D, and from there F, and then you have to descend. Similarly, from C you can go to K, but then you have to descend. There is no upward path from A to H, so A is not related to H. A cannot be a point of meet. When you look at B, then B is related to C and B is related to H. So B is a point of meet. So anything that comes in the downward direction in this network, all of that, all of them will be a part of your lower bounds. This is your point of meet, right? Similarly, if you look at J, okay, we will look at J later on. So B and everything here, which is X, Y, and Z. Similarly, if you look at J, then J is related to C and J is related to H also. So J is also a point of meet. Okay, so basically you have two meet points. Let me use it as M1 and M2 just to denote. So there are two different meet points. So union M, and then whatever comes in the network from in the downward direction, but there's nothing. So it will be not M, it will be J, union J. This is your lower bound of S. Now, as you can see, this B is point of meet and this J is point of meet. So your point of meet is not unique. What does it mean? It means that in your lower bound of S1, which is B, X, Y, Z, and J, this is your lower bound of S1. You do not have the greatest element in within the lower bound of S1. And what is that? This is your lower bound of S1, right? This is your lower bound of S1. So within this lower bound of S1, there is no greatest element because J and B both are point of meet, and uh, J is not related to B and B is not related to J. So there do not exist an element to which every other element is related to within this set of elements which is in the lower bound of S1. Okay, so there is no greatest lower bound. Greatest lower bound of S1 is equal to do not exist. Okay, now let's look at second example. Second set means lower bound of S2. So I'm erasing it now. So lower bound of S2, what are the elements? What are the elements in S2? C, D, and H. C, D, and H. Now you come one step down. This is C. So C is related to C, but C is not related to H. So you and similarly, if you look at D also, then D is related to D, but D is not related to H, and D is not related to C. So now you go two step down from C. So you have A, B, and J. So A is related to D, A is related to C, but A is not related to H. So A cannot be a point of meet. B is related to C, B is related to D, and B is related to H. So B is a point of meet. So everything in the downward direction, all of these nodes will be part of your lower bound Z. Similarly, if you look at J, then J is related to C, J is related to D, and J is related to H. So union H, union J. Just I think is the same. The set is same as the lower bound of S1 also. Okay. Now let's look at. So there is not going to be any greatest lower bound. Let's look at S2, which is C, D, and H. Oh, S2 is done. Let's look at now S3, D and G. Then lower bound of S3 is equal to D and G. Get one step down from D, you have C. C is related to D and C is related to G. So C is a point of meet. C comma everything that comes under C, all of them will be a part of your lower bound. So A, B, J, X, Y, Z. A, B, J, X, Y, Z. So, and there's only one direction in the down, there's only one way you can go in the downward direction from D. So I think that is covered now. When it comes to G, the you have H and I. One step below G is H and I. H is not related to D. I is not related to D. So that's it. This is your lower bound of S3. So as you can see, there is only one point of meet, which is this C. So this is your greatest lower bound also. Greatest lower bound of S3 is equal to C. Okay. Let's look at lower bound of S4 now. Lower bound of S4. So what is S4? S4 is F and G. F and G. Okay. So F is not related to G, G is not related to F. You go one step down from F, you have D here, you have K here, and you have H here. So when it comes to D, then D is related to F, but D is not related to G, so D is not a point of meet. When it comes to K, K is related to F and K is related to G. K is related to F and K is related to G, so K is a point of meet. And then everything that comes under in the downward network of K, everything in the connected downward network of K is going to be part of your lower bound. So C, H, A, B, J, X, Y, Z, all of them. C, H, A, B, J, X, Y, and Z. Okay. S5 is F and E. So what is the greatest lower bound? What is the greatest lower bound of S4? There is only one point of meet, which is K. So this is what your actually actually if you see this, this Hasse diagram, this is redundant edge. Forget it. This is a transitive edge. Okay, because H is related to K, K is related to F, so H is related to F. This was a this cannot be a part of your Hasse diagram. Greatest lower bound of S4 is K, because K is your unique point of meet. Let's look at S5 now. Lower bound of S5. S5 is F and E. F and E. So E is not related to F, F is not related to E. coming one step down from E, you have D, and one step down from F, you have D and K. We will look at K in a little while, but if you look at if you look at D, then D is related to E and D is related to F. So D is a point of meet. So everything that comes in the below network in the downward means from every node, if there is an upward path to the all of those nodes will be part of your lower bound. So C is going to be there A D J A B J X Y Z D C A B J X Y Z. Now one step down from F is K, right? K is related to F, but K is not related to E, so K is not your point of meet. So there is unique point of meet which is D. So greatest lower bound of S5 is D. Okay.
मैं भूत हूँ भूत गायब होता है
Thank you very much.